This video is about Chapter 4 and Lesson 3, and it's about functions. And what functions are they are a nice way for mathematicians to write equations of lines and that show the values that they're going to plug into an equation. So, for instance, typically we write equations as y equals mx plus b. And what we do when we want to plug a number or put a number into the equation, what we'll do is we'll put a semicolon and then we'll say x equals 3. And the way that we read this is we say that y equals mx plus b. The semicolon means when x equals 3. So if we were to write problem number 1 in regular notation, what we would do is we would write y equals 4x when x equals 6. And so if you look at problem number 1, see where the 6 is here, and it wants, what they're doing is when they write f of 6, so this means f of 6, what they want you to do is they want you to take the 6 and put it into the equation for x. So what they're doing, what they really want you to do is they want you to do this. They want you to write f of 6 when x is 6 is 4 times 6 is 24. And that would be the answer to problem number 1, is 24. Let's look at problem number 2, just to give you another example. It says that f of it wants you to find each function's value. So what we do is we take the function f of x is equal to x plus 11, and we let x equal 8. So we're going to say f of 8 is equal to 8 plus 11, which is 19. Let's look at problem number 3. Problem number 3 has f of 3 equals 2x plus 4. So that means we're going to do 2 times 3 plus 4 is 6 plus 4 is equal to 10. Equal to 10. So our answer for number 3 would be 10. Our answer to number 2 would have been 19. And let's look at number 4. Number 4 has the function at they want you to evaluate the function at 5. So what we do is we write the 3x minus 2 next to the equal sign, and then we plug in the 5. So we do 3 times 5 minus 2 is 15. 3 times 5 is 15. And let me erase that so it looks a little bit better. Is 15 minus 2 is equal to 13. And that would be the answer to number 4. Okay, the next problem is problem number 5. And in problem number 5, we want to continue along this idea where what we're doing is we're going to take this number that we put into f of x. So again, this notation right here is called f of x. Okay, so what's happening is we're going to put, when we write like we do here in all of these problems, you can see they're putting numbers inside the parentheses instead of the x. And so what we're doing is we're saying it's f of negative 6 in problem number 5. So what we want to do is, again, is we want to take that negative 6 and we want to plug it into the equation 4x plus 7 for the x. So we're going to take the 4 and we're going to put in negative 6 for x, and then we're going to add 7 to it. So we get negative 24 plus 7 is a negative 17 would be the answer for number 5. For number 6, what's going to happen is we're going to take, so for number 6, we're going to take the f of negative 14 and we're going to put it into the 2x minus 3. So we get 2 times negative 14 minus 3 would equal negative 28 minus 3 would equal negative 31 for number 6. For number 7, let's see what we get here. We have 2 9ths going into 7. Well, we have fractions going into 7, 8, and 9. And just in the, we'll have some problems like this on our project. So let's go ahead and not do these. Let's strike problems 7, 8, and 9 from the homework. Instead, let's skip to problem number 10. And the idea behind problem number 10, 11, and 12 is they want us to, it says choose 4 values of x to make a function table for each function. Then state the domain and range of the function. All right, so what I would do is I'm going to select easy numbers to put into the equation to make my math easier. So if I get to choose 4 values, I'm going to choose 4 numbers that make sense. So some easy math comes from multiplying from 0, 1, 2, and 3. So those are the numbers I'm going to choose. And let's go ahead, and then it says to make a function table for each function. So basically what that means is to calculate where x is 0. So we're going to do 5 times 0 minus 4 would be 0 minus 4 is negative 4. Then we would do 5 times 1 minus 4 would be 5 minus 4 would be 1. 5 times 2, and then that's supposed to be a minus 4. That's times 2, and then minus 4 would be 10 minus 4 is 6. And then we have 5 times 3 minus 4 is 15 minus 4 would be 11. And notice that our slope here is the 5. And what's happening is this is changing 5 each time. And in our answers, just like they're supposed to. So if this is x and this is y, the y value should be incrementing by the value of the slope each time. And the value of our slope in this problem is 5. Okay, so the next thing it asks us to do is to state the domain and the range. I'm going to do this the easy way. The domain are these numbers here, the 0, 1, 2, and 3, and the range are these values, the negative 4, 1, 6, and 11. Those are the range, and the 0, 1, 2, and 3, that is the domain. So let's go on to problem number 11, and let's just do this real quick, right? So if you get the point and you want to work ahead, go ahead. You can skip forward on the video. But for everybody else, I'm going to do these problems 0, 1, and I'm going to use simple points 0, 1, 2, and 3, and then I'm going to do 2 minus 3 times 0 would be, well, 2 minus 0 would be 2. And then we're going to do 2 minus 3 times 1. So 2 minus 3 is negative 1. And then it's going to be 2 minus, it ends up being 6, and my head's running faster than my mouth. So it's 3 times 2, and so 2 minus 6 is negative 4, and then it's going to be 2 minus 3 times 3, and so that would be 2 minus 9 would be negative 7. And again, you can see here where our slope is negative 3, and each time we are going down 3 on the y-axis when we for our range. So again, to identify the domain and range here, the domain is the set of x values. It's the 0, 1, 2, and 3. And the range is the set of y values, or in this case, the function output, or the f of x. So our range would be the negative 7, negative 4, negative 1, and positive 2. Notice how I'm doing them in numeric order. Okay, number 12. Again, I'm going to pick simple numbers. I'm going to pick 0, 1, 2, and 3. And I'm going to do 6 plus 2 times 0. And 6 plus 0 is 6. 6 plus 2 times 1 is 6 plus 2 is 8. 6 plus 2 times 2 is 10. And 6 plus 2 times 3 is 12. And our domain, well, our domain is the set of x values. Whoops, wrote that down wrong. Meant to write a D, not a B. So our domain is the 0, 1, 2, 3, and our range is the 6, 8, 10, and 12. Moving on to the next 3 problems. I'm gonna let you do these on your own because it's really just more of the same. Pick 4 numbers. You can use the 0, 1, 2, and 3 if you want, and then write in, and then do the calculation in the middle, and then write in the answer at the right. Identify your domain, and then identify your range. Will be your responsibility. All right, number 16. The school baseball team wants to have each player's name imprinted on the player's jacket. The cost is $75 plus $8.50 for each name. So wouldn't it make sense that we say that the cost is $75 plus $8 per name? So write a function to represent the cost for n names. Okay, so it's going to be 75 plus 8.5 per name, n. And so it'll be the cost is equal to 75 plus 8.5n. Now, the thing is that this isn't the right way of writing it, okay? And so what you're supposed to do is you have to fix this, and the cost should be 8.5n plus the 75. We want to use y equals mx plus b, where y is first, then the slope, which is the $8.50 per name, and then the x, and in this case, the input is the number of names that they're going to have, or the number of jackets, and then plus 75. So so be careful that you're using y equals mx plus b, and that you use the letter equals a number times a letter plus a number. That's the right way of doing it. Okay, and then it asks us in the story problem to write a function to represent the cost, and this is the cost. And then it says, what is the cost to have names imprinted on 25 jackets? So that just means that you're going to do 8.5 times 25 names plus $75. So multiply that out and write it out, and that's your answer. I don't have a calculator on me today, so you're going to have to do that problem, the multiplying it out. Okay, number 17. Number 17. This again was number 16. Number 17, they're going to make some lemonade. Gene sold 10 glasses of lemonade while setting up his lemonade stand. After opening, he sold an average of 20 glasses per each hour, which you can say 20 glasses per hour. So again, when you're reading these story problems, pay attention to trying to insert the word per whenever you see a number like that. Write a function to represent the approximate number of glasses of lemonade he sold after H hours. About when did he sell the 100th glass of lemonade? All right. So the thing is so G of H is the glasses per hour. So notice that they're wanting us to use function notation. So what they're trying to find is the glasses per hour. And remember that we put what we're trying to find in place of y in the equation. And then it's after H hours. Well, the thing is that if we're doing mx plus b, what's happening is he's really starting with 10 glasses sold. And that starting value is that fixed number that we care about is the y-intercept. And then he's selling 20 glasses per hour after he opens. So that's our slope, is the $20 per hour, and H is the variable. And this H should match this H in the equation if you're doing it right. Okay. Then what they do is they ask us about when did he sell the 100th glass of lemonade. Well, the thing is what they're doing is they're saying the answer, or what we usually try to find, is the number of glasses sold. Well, they're saying that the glasses sold is 100. So what we want to do is we want to put the 100 on the left side this time rather than in the H. And what we're going to do is we're going to do 20H plus 10 like this. And what we're doing is we're saying that the number of glasses is 100. And then we want to solve backwards. So if we subtract 10, we get 90 is equal to 20H. And then we divide by 20. And we find out that H is equal to 4.5. And so for us, that means that they sold about 100 glasses in about 4.5 hours. And that would be the answer to number 17. They sold the 100 glasses in about 4.5 hours. And let me reposition this so it looks right. Like that. Okay, done.